Hi, it's Naomi. It's currently Friday, October 3rd, and I'll be going over the whole action potential process. So, um, starting off, we'll start off with the resting membrane potential, and that just means it's the actual value of the electrical potential of the plasma membrane, and that just means it's ready to send a signal down the axon hillock of the axon and the neurons. So that'll be seen at negative 70 millivoltage. And it'll be shown by like both the sodium and the potassium gates being closed. So as it's ready to send its signal down, it's going to go up a bit into this local potential stage, and which just means there's going to be a short change in the voltage as it shifts into that point of depolarization. So as it moves up into the positive direction, this can be triggered by any chemical stimulus like other chemicals involved or temperature change or light. And it's going to just shift in that positive direction until it reaches negative 55 millivolts. And at this point in this threshold potential, we can begin depolarization. And when that happens, the sodium gate is going to open, and the potassium gate will be slightly open, but not like quite there yet. So as this opens, it's going to diffuse the sodium ions through the gate from the extracellular fluid to the intracellular fluid. And it's going to cause a rapid diffusion, which means it's also going to be a rapid depolarization as it goes up. And as it continues up, it's going to reach 0 millivolts and then eventually get to the peak at a positive 35 millivolts. And at this action potential peak, it's going to close the sodium gate and open up the potassium gate a lot more. And this will allow the potassium ions to diffuse from the intracellular fluid to the extracellular fluid. So that'll be happening up here. And once it reaches that point, it'll go back down into this stage of potential repolarization. And as it goes down, it's going to get more negative as the cations are exiting the plasma membrane. And it'll eventually go down back to negative 70 millivolts. And once it's at that stage, both gates will be closed as they have switched. And then it'll go back to that resting membrane stage, potential stage, and it will continue that whole cycle of action potential. It's going to continue that whole process in the axon of the neurons as the electrical signals are moving down the neurons to their target cells. And you can sort of think of it as the New York subway system, where the train is going down the tracks and stopping at a bunch of points, and a bunch of people going in and out at those stops until it reaches its final destination, the last stop. So